Have you ever wanted to build a clock that's always accurate to the second without the hassle of real-time clock modules? Or perhaps you're intrigued by time-triggered DIY automations? Well, you're in for a treat. Hello and welcome to our channel. Today, we're diving into an exciting project that eliminates the need for RTC modules. We'll be using the NodeMCU and NTP, Network Time Protocol, to create a real-time clock display. In this video, we'll guide you through harnessing the power of the NodeMCU and NTP to fetch the precise time from the internet, and display it on a small OLED screen, followed by triggering an example automation at a specific time of the day. Let's jump in and discover how you can achieve this impressive feat. To embark on this journey, you'll need a NodeMCU, ESP8266 module, a 0.96 OLED display, and a small LED or buzzer for our time-triggered automation. If you're new to the world of ESP8266, we recommend watching our Getting Started video before proceeding. It will help lay the foundation with this powerful microcontroller. Let's start by setting up our development environment. You'll need the trusted Arduino IDE and the ESP8266 board. Don't worry if you're new to this, we'll guide you through the installation process step by step. Open the Arduino IDE and navigate to Files, Preferences. In the Additional Board Manager URL field, paste the following code and click OK. You can also find this code in the description below. This will prepare your IDE to download the board for your NodeMCU. Once done, go to Tools, Boards Manager. Search for ESP8266 and install it. Next, let's proceed with installing the necessary libraries. Click on Sketch, Include Library, Manage Libraries. Search for and install the following libraries, as they will play a crucial role during the coding process. With the software side covered, let's move on to the hardware. Use the provided diagram for the connections. We'll connect our ESP8266 to the internet via Wi-Fi and hook it up to a small OLED display. This display will elegantly showcase the current time and date fetched from the NTP servers. And the best part? No RTC modules required. Let's delve into the heart of our project, the code. To begin, we'll import the essential libraries. We'll include the ESP8266 Wi-Fi library for Wi-Fi connectivity, NTP client for accessing the NTP server, Wi-Fi UDP for UDP communication, and Adafruit SSD1306 to seamlessly control our OLED display. As we move forward, the code sets up constants and variables. These encompass Wi-Fi credentials, pin numbers for the LED and buzzer, activation and deactivation times, and arrays to manage days and months. Subsequently, we'll initialize our OLED display with the help of the Adafruit SSD1306 library. This display object becomes our canvas to present information. Next, the Wi-Fi Connect function takes charge of linking our ESP8266 to a Wi-Fi network. It skillfully updates the OLED display to reflect the connection status. Next in line is the clock display function. It captures time from an NTP server using Time Client and elegantly showcases it on the OLED screen. Even the conversion to a friendlier 12-hour format is seamlessly handled. Introducing the device activation function. This function scrutinizes the current time against the set activation and deactivation times. If the moment falls within the designated interval, the LED comes to life, otherwise, it takes a breather. And now, for an extra dash of creativity, let's add an enchanting touch. Text that gracefully scrolls across the OLED display. This delightful animation is a splendid method to convey supplementary information, warm greetings, or messages in your projects. Behold the text scroll function, the mastermind behind this text scrolling feat. With the X and Minx variables at our disposal, we steer the scrolling phenomenon. Turning our attention to the setup function. Here, we initiate the display, configure pins for both the LED and buzzer, establish a Wi-Fi connection, start the NTP client, and establish the initial state of the LED based on the present time. And last but not least, the loop function embraces the core logic of our project. It orchestrates clock updates, text scrolling, and checks the device activation status. If the state experiences a change, a brief buzz from the buzzer marks the occasion. Now, it's time to upload the code. Ensure that you've selected the correct board and port and that the module is connected to your computer. There you have it, fellow creators. With the ESP8266 and NTP by your side, you've learned how to craft a real-time clock display without the need for RTC modules. As we upload the code, you'll witness the LED and buzzer activation and deactivation as programmed. This opens doors to endless possibilities, from enhancing smart home automation to personalizing countdowns and event reminders. The complete code and resources are waiting for you in the video description below. If you found this tutorial valuable, don't forget to give it a thumbs up and hit that subscribe button. Thanks for tuning in, and remember, the future is now, so let's create something incredible.